Today my lesson is about angles at the circle. Circle is a set of points, of course, which are at the same distance from the center, which is a fixed point rather, and that fixed distance is called the radius. And now we are talking about the arc of a circle, which is a part of a circle, is called arc. And this arc now, what I am pointing out, is subtending an angle at the center, and the measure is given here 100 degrees. The arc, what we are talking about, is subtending an angle about 50 degrees, half of this 100 degrees, at any point in the remaining part of the circle. Okay, so I want to show you how exactly it is 50 degrees. Wherever you take it, it is only 50 degrees. And that tells you very categorically one thing, that angles in the same segment are equal. Wherever you take the point on the remaining part of the circle, the angle is only 50 degrees. The theorem here essentially is the angle subtended by an arc at the center of the circle is twice the angle subtended by that arc at any point in the remaining part of the circle. And let us study this a few more examples. I want to change the angle at the center. When I increase the angle at the center, now let us say it is 126 degrees at the center. And essentially the angle at the remaining point of the remaining part of the circle is half of that 126 degrees, that is 63 degrees. So this is how we can verify. We can reduce the angle, we can take an acute angle. Now it is only 54 degrees at the center, 52 degrees at the center, and at any point of the remaining part of the circle it is only 26 degrees, half of that 52 degrees. And I can increase it, I can make, say, an obtuse angle, and now the angle is about 212 degrees, and half of that is 106 degrees at a point on the remaining part of the circle. So we should understand one thing: when you're talking about a minor segment, the angle is obtuse, it's more than 90 degrees. And when you take a major segment, the angle is acute, it's less than 90 degrees. But let us watch the measure of the angle when we take at the center 80 degrees. That's, I just want to put 180 degrees there. Now it is 180. Angle at the center is 180 degrees, and at any point on the remaining part of the circle, the angle is a right angle. So what you observe here is that angle in a semicircle is a right angle. So wherever you take this point, consider that point, the angle is all the time, it is about 90 degrees, half of 180 degrees. So if you have a straight angle here at the center, the angle here at remaining part of the circle, at any point in the remaining part of the circle, is a right angle actually. So this is an important observation that we are going to make. We are verifying this theorem. So later what I want to do is that here you find a tangent. A tangent is a line which touches the circle at only one point, and at the point of contact where this tangent is meeting the circle, we have drawn a card, and this is the card we have drawn at the point of contact. And you can see this angle it's in black color, angle between the tangent and the card drawn at the point of contact. You can see this angle there. The measure of this angle is 61 degrees, and this 61 degrees, you see again it's in red color there, 61 degrees. So what is this theorem now? It is alternate segment theorem. The angle between the tangent and the card drawn at the point of contact is equal to the angle in the alternate segment. So watch this again. I want to change the angle, and you see here now the black angle is a 58 degrees here. So the angle between the tangent and the card drawn at the point of contact is 58 degrees. The same angle you can find out in the angle in the alternate segment. This is also 58 degrees. So the theorem here says that the angle between the tangent and the card drawn at the point of contact is equal to the angle in the alternate segment. So what I want to tell you very categorically here is that there are several theorems we have learnt here. Theorem number 1 is that angle subtended by an arc at the center of the circle is twice the angle subtended by that arc at any point of the remaining part of the circle. Angle in a major segment is an acute angle, angle in a minor segment is an obtuse angle, and angle in a semicircle is a right angle. So we are trying to verify all these theorems in a jiffy, and finally we studied alternate segment theorem, which states that the angle between the tangent and the card drawn at the point of contact is equal to the angle in the alternate segment. Let us verify once again all these theorems very quickly, for a revision sake. Now this is minor arc, okay, what we are considering here, and this is subtending at the center an angle of 98 degrees, and at any point on the remaining part of the circle you should have half of 98, and therefore this red angle is 49 degrees. And that 49 degrees, the measure does not vary even if you take the point anywhere on the remaining part of the circle, and therefore the theorem here is angle subtended by an arc at the center is always twice the angle subtended by that arc at any point on the remaining part of the circle. That is the first theorem we are talking about. And the simple one which follows here is that angles in the same segment are equal. Now we are increasing the measure of the angle at the center, and we are equating that to 180 degrees. And when you have 180 degrees at the center, this is the diameter, you can identify that, and the angle subtended by this arc, the semicircle, at any point in the remaining part of the circle is half of 180 degrees, that is 90 degrees. So you can study here that angle in a semicircle, wherever you take that point, these are all right angle triangles, of course, as you see them, and this angle is very specifically, it is 90 degrees. And I want to increase the angle at the center further, making this a reflex angle. Here the angle is 200, measure of that is 230 degrees, and therefore the angle here is 115 degrees. This is 230 degrees at the center, and therefore it is 150 degrees there. And we also understand one thing, this is an obtuse angle, 115 degrees, for a specific reason, that this segment we are talking about is a minor segment. Angle in a minor segment is an obtuse angle. And then we reduced this to study the alternate segment theorem, and alternate segment theorem talks about the angle between the tangent and the chord drawn at the point of contact. Chord is any line segment which joins 2 points on the circle, any 2 points. And you also know that the longest chord is the diameter there. So this is the tangent and this is the point of contact, and we drew a chord there at the point of contact, and the angle between them, here it is 62 degrees, and the same 62 degrees you will find here in the alternate segment there. And therefore angle between the tangent drawn and the chord tangent and the chord drawn at the point of contact is equal to the angle in the alternate segment. These are the theorems you have maybe for grade 10 or grade 9 in circles. Thank you so much.